My dear students, welcome back to our channel. In this video, I will be explaining the Bachelor of Computer Applications 4th semester subject Network Security as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 3, the important short question is symmetric key length. In network security, symmetric key is a method where the same key is used to lock, encrypt, and unlock, decrypt a message. Key length means how long the key is. Longer keys are harder for hackers to break. Example: imagine you and your friend have a secret code. If your key is just 123, it's easy for someone to guess. But if your key is #3#4PZ7Q, it's much harder to crack. That's a longer key, and it gives better security. Common key lengths: 56-bit, like old this, not safe today. 128-bit or 256-bit, used in AES, very strong and safe. Easy trick to remember. Longer key is equal to stronger lock. Just like a big lock is harder to break, a longer key makes your data more secure. So, symmetric key length is all about how strong your digital lock is. Next important short question is 2. What is store backup? Store backup means saving a copy of your important data in another safe place, so you don't lose it if something goes wrong. Example: imagine you are writing your school project on your laptop. If the laptop crashes or gets stolen, your work is gone. But if you saved a copy on a pen drive or Google Drive, you can still get it back. That's store backup. Why it's important? Protects you from data loss. Helps during virus attacks or system crash. Useful if you accidentally delete something. Types of backup storage: external devices like hard drives, pen drives. Cloud storage like Google Drive, OneDrive. Easy trick to remember. Copy today, save tomorrow. Just like you keep a duplicate key for your house, always keep a backup of your files. Store backup is your safety net in the digital world. Next important short question is 3. Black replay. In network security, a black replay attack is when a hacker captures a message or data and sends it again, replays it, to trick the system. Example: imagine you send a message to your bank app, send 1000 rupee to Rahul. A hacker secretly records that message. Later, they replay the same message without your permission. Now 1000 rupees is sent again. You didn't send it the second time, but the system thinks you did. This kind of attack is dangerous because the hacker doesn't need to know your password, they just reuse your original message. How to stop it? Use timestamps, like expiry time on the message. Use unique message IDs. Add encryption and digital signatures. Easy trick to remember. Don't replay the play. Like watching a cricket replay doesn't count as a new match, a replayed message should not be treated as new. Next important short question is 4. What is counter mode? Counter mode, CTR. In network security, counter mode, CTR, is a smart way of encrypting data using a number called a counter. It is used with symmetric encryption to make data safe. Example: imagine you want to send a secret message. Instead of locking each part of the message directly, you first take a number, the counter, mix it with a secret key, and then lock the message. Each part of the message gets a different counter number. This makes the encryption fast and secure, and it also allows different parts of the message to be locked and unlocked at the same time. Why it's useful? Fast, great for streaming or large files. Parallel encryption can work on many parts at once. Secure, harder for hackers to guess. Easy trick to remember. CTR is equal to count, encrypt, repeat. Just like counting steps while walking, CTR counts for each block of data, making sure every part is safely locked. Next. Unit 3 important. Long questions. First important long question is 1. Algorithm types and modes. In network security, we use algorithms to protect data by turning it into unreadable code, encryption, and back into normal form, decryption. Algorithms are like secret methods to lock and unlock your information. Types of algorithms. 1. Symmetric key algorithm. Same key is used to encrypt and decrypt the data. Fast and good for large data. But both sender and receiver need to keep the key secret. Examples: AES, DES. Imagine you and your friend use the same key to open a diary. If someone steals the key, they can read everything. 2. Asymmetric key algorithm. Uses two keys, one to encrypt, public key, and one to decrypt, private key. More secure but slower than symmetric. Examples: RSA, ECC. It's like a mailbox, anyone can drop a letter, public key, but only you can open it with your key, private key. Modes of operation for symmetric algorithms. Modes decide how data is encrypted block by block. Think of it as different styles of using the same algorithm. 1. ECB, Electronic Codebook Mode. Simple, but not secure for sensitive data. Same data block is equal to same output. Hackers can guess patterns. 2. CBC, Cipher Blockchaining. Each block is mixed with the previous one. More secure than ECB, but slower. 3. CTR, Counter Mode. Uses a counter for each block. Very fast and works well for streaming or large files. 4. GCM, Gallows Counter Mode. Like CTR but adds authentication, extra security check. Used in modern systems like secure websites, HTTPS. Easy trick to remember. Symmetric is equal to same key. Asymmetric is equal to two keys. Modes is equal to the way you use the algorithm. Algorithm is the lock, mode is how you turn the key. Next important long question is 2. Electronic Codebook, ECB. In network security, Electronic Codebook, ECB, is the simplest mode of encryption used with symmetric key algorithms like AES or DES. It breaks the data into small blocks and encrypts each block separately using the same key. How ECB works? Your data is divided into fixed size blocks, for example, 128 bits each. Each block is encrypted independently with the same key. The result is the encrypted message. Example: imagine writing a message. Hello, hello, hello. ECB will break it like this. HEL, LOH, LO. Now, each repeating block, like HEL, will be encrypted in the same way, producing the same encrypted output. So, same input block is equal to same output block. Why ECB is not secure? Patterns can be seen in encrypted data. If someone notices repeating blocks, they can guess the original data. This makes ECB unsafe for important or sensitive information. Real-life example. If you encrypt an image using ECB, the shape of the image may still be visible in the encrypted version because patterns are not hidden. Where ECB is used, rarely. Only in cases where data is small and security is not a big issue. Example, encrypting short random values or test data. Easy trick to remember. ECB is equal to easy, but not clever and broken. Electronic codebook. Bad for security. Summary. ECB encrypts each block separately. Fast and simple, but not recommended for real-world use. Better alternatives, CBC, CTR, or GCM for stronger security. Next important long question is 3. Explain cipher block clouding with an example. Cipher blockchaining, CBC. In network security, cipher blockchaining, CBC, is a method or mode of encrypting data using symmetric key encryption. It is more secure than ECB because it hides patterns in the data by chaining the blocks together. How CBC works? Data is broken into blocks like small chunks. Before encrypting each block, it is combined, XORed, with the previous encrypted block. This creates a chain effect, so each block depends on the one before it. The first block uses a random value called an 4 initialization vector to start the chain. Example. Let's say your message is hello 1 2 3 4 5 6 divided into blocks, hell, 0123, 456. 1. Hell is XORed with the 4, then encrypted. 2. The output is used to XOR with 0123, then encrypted. 3. The output is used again for the next block, and so on. This way, even if two blocks of data are the same, their encrypted outputs will be different because of the chaining. Why CBC is better than ECB? Hides patterns in the data. Safer for encrypting messages, images, or files. Even if a hacker sees the encrypted data, they can't figure out the original easily. Limitations of CBC. It must be encrypted in order, not parallel, so it can be a bit slower than other modes like CTR. If one block is damaged or changed, it affects the next block too. Easy trick to remember. CBC is equal to chained blocks are connected. Every block depends on the last one. Like a chain of locked boxes, open one, you need the one before it. Summary. CBC adds extra security by linking blocks. Uses 4 to start and prevents pattern repetition. A great choice for encrypting confidential data. Next important long question is 4. Write in detail about stream ciphers with an example. Stream ciphers. In network security, a stream cipher is a method of encrypting data one bit or byte at a time, instead of in big blocks like block ciphers. It's fast, simple, and works great for real-time communication like video calls, chats, and live data transfer. How stream ciphers work? A stream cipher takes the original message, called plaintext, and mixes it with a secret key stream, a series of random-looking bits. This mixing is usually done using a method called XOR, exclusive OR. It encrypts data bit by bit or byte by byte. Example. Imagine you are chatting with a friend on WhatsApp. 1. Your message, hello. 2. Stream cipher creates a key stream, something like X9R2T. 3. Each letter in your message is XORed with one character from the key stream. 4. The output is a secret code sent to your friend. Your friend, using the same key stream, can decrypt it back to hello. Where stream ciphers are used. Online streaming, YouTube, Netflix. Live calls and chats, WhatsApp, Zoom. Wireless networks, like Wi-Fi encryption. Advantages: fast and efficient, perfect for live data. Less memory required. Works well on small or continuous data. Disadvantages: if the key stream is reused, security breaks. Needs good random key generators to be safe. Famous stream ciphers: RC4, used in older Wi-Fi. Salsa 20 and Cha-Cha 20, used in modern apps. Easy trick to remember. Stream cipher is equal to flows like a stream. It locks each drop, bit-byte, of data as it flows. Summary: stream ciphers encrypt data 1 bit-byte at a time. Ideal for live, fast communication. Simple, quick, and effective, like locking each word as you speak. Next important long question is: 5. Using algorithms in network security. In network security, algorithms are like secret codes used to protect your data. They transform the data into an unreadable form, encryption, and convert it back to normal, decryption. Think of algorithms as powerful tools that help keep your personal information, like passwords and messages, safe from hackers. How algorithms work in network security. 1. Encryption. When you send data, like a message or credit card number, the algorithm scrambles the information using a secret key. This makes it unreadable to anyone except the person who has the correct key to decrypt it. 2. Decryption. The receiver uses the same or a different key, depending on the algorithm, to convert the scrambled data back into its original form. This ensures that only authorized users can access the real information. Example: imagine you are sending a secret message to your friend, "Meet me at 5 p.m. 1. You use an algorithm like AES to encrypt the message. Now, the message looks like a random string of numbers and letters, 1 to F4B to B8C5. 2. Your friend uses the same key to decrypt it and read the message, "Meet me at 5 p.m. Types of algorithms used in network security. 1. Symmetric algorithms. Same key is used for both encryption and decryption. Example: AES, DES. Fast and efficient, but the key must be kept secret. 2. Asymmetric algorithms. Two keys are used, one for encryption, public key, and one for decryption, private key. Example: RSA. Safer because the encryption key can be shared publicly, but decryption remains private. Where algorithms are used. Secure websites, HTTPS. Online banking, encrypting transactions. Email, protecting attachments and content. Easy trick to remember. Algorithm is equal to secret recipe. Just like a recipe helps you make a dish, an algorithm helps you secure data. Next important long question is: 6. Compare between public key versus symmetric encrypting. Public key versus symmetric encryption. In network security, encryption is the process of turning readable data, called plaintext, into unreadable code, called ciphertext, to keep it safe. There are two main types of encryption: public key encryption, also called asymmetric encryption, and symmetric encryption. Let's break them down in simple terms. Symmetric encryption. In symmetric encryption, the same key is used to both encrypt and decrypt the data. It's like having a single key that locks and unlocks a door. Example: if you want to send a secret message to your friend, you both need to have the same key. You use this key to encrypt the message before sending it, and your friend uses the same key to decrypt it and read the message. Algorithms used: AES, DES, RC4. Speed, fast, because it uses simple operations to encrypt and decrypt data. problem, both people need to share the key securely. If someone else gets the key, they can read your messages too. Public key encryption. In public key encryption, there are two keys. 1. Public key. This key can be shared openly with anyone. 2. Private key. This key stays secret and is only known to the person who owns it. Example, if you want to send a secret message to someone, you use their public key to encrypt the message. Only the person with the matching private key can decrypt it and read the message. Algorithms used RSA, ECC. Speed, slower than symmetric encryption because it uses complex calculations. Security, it's more secure because you don't need to share the private key, and it's much harder for hackers to crack. Comparison between public key and symmetric encryption. Feature symmetric encryption, public key encryption. Key used same key for encryption and decryption, different keys, public for encryption, private for decryption. Speed, fast, slower. Security, less secure if the key is shared or stolen, more secure because the private key is kept secret. Example, algorithms AES, DES, RC4, RSA, ECC. Easy trick to remember. Symmetric is equal to same key, one key to do everything. Public key is equal to two keys, public to encrypt, private to decrypt. Summary. Symmetric encryption is fast but requires safe key sharing. Public key encryption is slower but much more secure, especially for online communication. Next important long question is 7. Communication channels in network security. In network security, a communication channel is the path through which data travels from one device to another. This channel can be physical, like cables, or virtual, like wireless signals. Understanding these channels is important because they help us secure the data being transferred. Types of communication channels. 1. Wired channels. These are physical connections like Ethernet cables, fiber optics, or telephone lines. Data travels through these cables, and they are usually more secure because they are harder to intercept. Example, imagine you send a letter inside an envelope. The envelope keeps the letter safe, just like cables keep the data secure from outside interference. 2. Wireless channels. These include Wi-Fi, Bluetooth, radio waves, and satellite communication. Data travels through the air and is more vulnerable to eavesdropping or hacking. Example. Think of sending a letter without an envelope. It's more likely that someone could read it if they are close enough. Why communication channels matter for security? The security of the channel is crucial because hackers might try to intercept or tamper with the data traveling across it. To protect the data, we use techniques like encryption and firewalls. Encryption, it scrambles the data so that even if someone intercepts it, they can't read it. Example, if you are sending an important email over Wi-Fi, encryption ensures that even if someone intercepts the message, it remains unreadable. Firewalls, these act like security guards and monitor incoming and outgoing data to stop unauthorized access. Common security measures for channels. 1. VPN, Virtual Private Network. This creates a secure tunnel over the internet to protect your data from hackers. 2. HTTPS, this is a secure version of HTTP that ensures data exchanged between a website and a user is encrypted. Easy trick to remember. Wired is equal to more secure, wireless is equal to watch out. Wired channels are more secure like a closed box, while wireless channels are more vulnerable like sending a letter in the open air. Summary. Wired channels are safer but less flexible. Wireless channels are more convenient but need extra security. I hope you understand easily each question. All the best, students, for your upcoming exam. For other subject, quick revision. Important questions. Previous question papers. And syllabus. Links are available in description. Check out once. Thank you for watching. Like and share this video with your friends.